Hello, my dear friends, my dear viewers. I am before you today uh, to make you practice 3 entrance examinations questions. The chapter 3 regarding the resistances, electric current, the current electricity chapter. No, don't get it so make don't think it is so difficult. By step, no, I will teach you to solve and understand the real essence of what is in that chapter. I cannot lecture you in a very big hectic words. No, I will not prefer in that way. I will just allow you to know what are all the range of questions asked in any entrance competitive examinations, and also I will be there with you how to solve each and every step, so that no, you already know that a certain level of students are there above 90%, etc. These people do not need any aid. They just will read about what are all they can solve it by their own reading skills. But some people are there who are even very weak, who are scoring 40% marks, 30% marks, etc. also. So I will aid them to be to the level of 90% and more. That's my aim, because no one is weak if they understand the fundamental basics in its real sense. So can we solve it? This is the thing. 3 questions are here, in which first question, whenever I draw a diagram like this, no, the question will not allow this much data in it. In this question, there is only a uh, a, a battery source having a 2-volt, and 3 resistance are there, which are just positioned as the sides of a triangle. And a triangle is given A, B, C, and the circuit is complete. So a current positive charge, this current will travel from here, it will go to the B, and it will split up into the BC and BAC, and then again it will join together. Sorry, this sign, this is mistaken. The thing is, these two will join again and will come over here and join here. That's the essence. So the question goes like this: a uniform wire of resistance 9 ohm. Okay, a uniform wire. Earlier in my PCM Guru Bro channel, it is given that a certain wire is taken which is having uniform resistance along its uniform unit length. That's what is mentioned over here also. A uniform wire of resistance 9 ohm is cut into 3 equal parts. They are connected in the form of an equilateral triangle ABC. Uniform wire is there. It is used to make a equilateral triangle like this. A uniform wire is taken, bent like this, and taken like this. And then these two ends, no, is connected to a battery. That's it. And cell of EMF 2-volt and negligible internal resistance. Okay, that cell is mentioned, 2-volt cell. Negligible internal resistance means there is a small r, no? There is a small r. If you just look at your book, revise that. A cell battery having an internal resistance small r is not to be taken because it is negligible. Is connected across B and C. So this cell is connected across B and C. What is the potential difference across AB? That's the question. What is the potential difference across AB? AB. What is the potential difference across this section? So first we want to solve, no, the whole circuit is having an effective resistance, no. Then only we can use a formula which is called V is equal to IR. The potential difference is equal to the current into the resistance. So first of all, solve this. We are only given the resistance and the voltage of the battery. So 3 ohm plus 3 ohm. That means these two are in series. Now, in the case of BAC, BA and AC are in series. BA and AC are in series. Series, then this plus this is equal to 6 ohm. This resistance and this resistance added to come R effective resistance 1. That is BAC resistance is 6 ohm. And this 6 ohm now is in parallel to this 3 ohm. So the parallel connection goes BAC parallel to BC. So then 1 by R effective is equal to 1 by 3. That means this resistance plus this resistance. So in the parallel connection, 1 by R effective is equal to 1 by R1 plus 1 by R2. R1 is this, R2 is this, which is found by this. So these two are in parallel, 1 by 3 ohm plus 1 by 6 ohm. When we solve this question, this thing making the denominator same, you will get 1 by R effective is equal to 1 by 2. Okay, 2 by 6 plus 1 by 6 is equal to 3 by 6. That means 1 by 2. That means R effective is equal to reciprocal of this. That is 2 by 1 is equal to 2. Okay, we got this 2. Answer, no. R effective 2. That is the whole thing, no. The whole wire which is made into equilateral triangle offers 2 ohm resistance to the whole circuit. That's the essence. And here in a box which I have shown now, that is this 2 volt divided by this 2 ohm now gives 1 ampere current. That means from this, earlier we only just known 2 volt battery and this 3 ohm mesh which is in the form of equilateral triangle. So from that, a 1 ampere current is emanating from this battery. You got the current amperage, 1 ampere. But here, we just want to know what is the voltage over here. But now also we are near to the answer only. This current, when it come over here at the junction rule, Kirchhoff's junction rule, we will know this current will split up into 2 parts. One part will go through BAC section, the other part will go to BC section, isn't it? So this one, how will you find out what is the current through this section and this section? That's the essence we have. No, you have to know current through BAC, the current through here, how much? The current through BAC is equal to I is equal to this 2 volt, plus what all resistance encountered by this. So BAC section has a resistance of 6 ohm, so this is written again like this. The 2 volt V is equal to I into this now. So I is equal to the voltage by what all resistance is offered by this BAC. So 2 volt by 3 plus 3 ohm. That is 2 by 6 equal to 1 by 3 ampere. That means we found out what? 1 by 3 ampere will go through here. 1 ampere comes over here and it will split into 2. That is 1 by 3 will go through this section and meet up here. Then what will be remaining? 1 by 3 is this, then 2 by 3 will be here. No, 1 by 3 plus 2 by 3 is 3 by 3, that is 1 ampere. So we will find out, really the current, 1 by 3 of the current will go through this section and 2 by 3 ampere will go through this section. I will make you understand a logic also. What are all the higher the resistance through a section, then that will only carry lower current. Do you find out through this diagram? And the next, a resistance. This section is having only half that resistance, so the double amount. Okay, understand this essence also. So we have found out the current through BAC section is equal to 1 by 3 ampere. The potential difference across AB. The first section, what is the potential difference? V is equal to IR. We know that, that is I current 1 by 3 ampere is going through this current and the resistance is 3 ohm, which is over here. So 1 volt is the potential difference across AB section. But now, if in the entrance examination, they can ask different sections of what is the potential difference across AC and BC also. So I have completed the question in a systemic way. That means potential difference across AC also. That means 1 by 3 ampere flows through this also. This 1 by 3 ampere flows through this area. So the same current is flowing through this also. So 1 by 3 ampere into the 3 ohm. That is AC also. The potential difference is 1 volt. What is the potential difference across BC? Isn't it? So the resistance we know, no, 3 ohm. And what is that current over here? Here 1 by 3 ampere. Then here what is remaining of 2 by 3? 1 minus 1 by 3 is equal to 2 by 3. That is the remaining. Okay. This area having 2 by 3. These two when added up give 1 ampere. So the 2 by 3 ampere into 3 ohm is equal to 2 volt. Hey, we do not want to calculate all this, but just look at this. When we calculate also, we will get this. These two sections, this resistance is applied with a voltage of 2 volt of the battery. No, that is again we have calculated in a very systemic way. So you practice well like this now. If you get a higher, tougher level question also, this is the essence which will make you evolved to solve that question. Can we go to the next level question? The thing is, question number 2 asks, a circuit is given. A 7 ampere current is going through this and it is splitting up into two sections, I1 and I2 current, and going through a 4 ohm resistance and then through 2 ohm resistance and coming out of C, this part. I2 will go through 10 ohm and then to 5 ohm and coming out of C. So the naming is A, B, C is the path of the top, A, D, C is the path of the bottom. And for making it easy, please download these videos in the download or see it in the maximum clarity possible, because I have made these videos in 720 pixel clarity so that you can see it clearly as a note, and also take out your note also from this thing. You can revise also very fast by my videos which I have created. Then don't compromise with the clarity, because these are the essences. This is a writing. It is not like cinema. Just understand these are writings. So just make it in the. I have also compressed my videos to a range of 100 MB or less than 100 MB. So just be with me, support me. The thing, this question which I have explained here, is furthermore simplification is done over here. That means this series resistances are added together to get this 6 ohm. When we the two resistances are series, then 4 plus 2 6, and this 10 plus 5 15. That is written over. This is diagram, but just read the question. The current of 7 ampere flows through the circuit. 7 ampere flows through the circuit. The potential difference across B and C is the same as that. What is the potential difference across B and C? What is this potential difference? What is the V in B and C? So how to start, where to start from to know that answer? So look at this figure. It is given that 7 ampere current, what is the potential difference between B and C? That's the question. That's the entrance level question. So when we look at it, this is a galvanometer bridge, That is why I have taught you in the earlier PCM Guru Bro channel classes, bridge, wheat stones, gehu, pathar bridge, somewhat like that, no? So, this bridge is the wheat stones bridge, having galvanometer bridge between these two resistances, these 4 resistances which are in position like this. So if you don't know anything about Wheatstone's bridge also, look at this. A current flow will be there, a supply will be there from left to right, or left to right. It is conventionally like that. And just if you don't know anything also, write this thing which are in series in the top part, that will be given name PQ, and the bottom part will be given RS, R and S. So the basic essence of that Wheatstone's bridge equation is P by Q is equal to R by S. Balanced Wheatstone bridge represents this equation. So here now substitute this value 4 by 2 is equal to 10 by 5. Hi, this is okay. This is a balanced Wheatstone's bridge. Then we want to understand the potential difference across 4 ohm and 2 ohm. Potential difference across 4 ohm and 2 ohm means first of all we want to understand if it is balanced, no current passes through this. So we can cut off this from there is no galvanometer, there is no current across this, there is no potential difference across this, there is no flow of current. That's why I have taken off this whole thing and written like this, because 4 ohm and 2 ohm which are in series will constitute 6 ohm, 10 ohm and 5 ohm constitutes 15 ohm. That's it, the simplified equation, the simplified diagram, 7 and 6 and 15. I1 and I2. I2 is this over here and I1 is over here. So in the ABC section, ABC is 6 ohm, the total are effective, and in the ADC bottom is 10 plus 15 ohm. Then the potential difference across the whole thing now here in the whole thing it will be V is equal to IR. What is the I over here? I1. I will name as I1. This is split up into I1 and I2 now. So I1 into this 6 ohm resistance. So I1 we do not know. Just make it a box. This section V is equal to I into 6 ohm, the total. I1 is equal to, then I will write what is the thing which is to be understood here is a rule which I am introducing right now to you. If a splitting comes like this, I1 and I2 splitting and come joining to the to form the to constitute the other side, joining to at the joint C, then you must use a rule called shunt rule just to solve like these questions. The shunt rule in a way is said that I1 current is said to be the current into the other side resistance, the 15 resistance divided by the total resistance. What's the proportion on the other side? That means I1 is equal to the current into this proportion, the other side whole resistance by the total resistance. That means this side is 6 now, this is 15 now. So this I1 is equal to 15 by 15 plus 6. Understand this. So as a rule now through ABC, I am writing, since the current branches into 2, the shunt rule can be written by a basic formula. I1 is equal to, that is I1 is over here. To find out over here, I1 is equal to the total current I which is supplied, the supplied current into the other side R2 which is over the other side divided by R2 plus R1, which are all encountered this whole resistance. Okay, the proportion ratio on the other side. Understand this very well. Thus I1 is equal to this other side whole resistance divided by this whole resistance. Okay, that is I1 is equal to 15 divided by 7 into 15 divided by 15 plus 6 is the essence. So can we solve this? 7 into 15 is equal to 105. 15 plus 6 is equal to 21 is equal to 105 by 21 is 20 into 5, 100. 105, okay, 5 ampere. So 5 ampere goes through here and 2 ampere goes through here. That means a lower resistance, then the current, majority of current through lower resistance, 5 ampere. Then the higher the resistance, 15 ohm, then 2 ampere. As far as what all the amount of resistance is there, lowest current will flow through that. So by heart this formula please for me. So this is the shunt rule. The other side the current, total current into other side resistance divided by the total resistance offered by the branching. Okay, understand this very well. Then potential difference across 2 ohm. Here now I1 is passing through 4 ohm and 2 ohm also. So I1 we have found out to be 5 ampere now. So here we just know I, and then we just know what is 4 ohm, 2 ohm or 4 ohm, which is this I1 is current passing through 4 ohm and 2 ohm. So this I1 current now, This I1 current is passing through, that is 5 ampere is passing through 2 ohm. That is I into R, 2 ohm is equal to 10 volt. The voltage over BC section is 10 volt. 5 ampere which is flowing through here, and the resistance offered was 2 ohm. That is 10 volt. Through across ADC, what is I2? Then across this ADC, the I2 current I want to find out. Now, what is I2 current? Then 7 into the total current into the other side resistance. That means through here. Then the other side is 6 by 6 plus 15. Okay, 15 plus 6. Okay, this is the shunt rule. So I2 current is equal to 42 by 21. 7, 6, 42. 15 plus 6, 21. That is 2 ampere. 2 ampere is going through this. Okay. By mathematics, I have found out. 7 minus 5 also you can find out. But entrance, what are all your convenience, make it. That's it. Your convenience. That's everyone has a genuine style. Every student is a creation of that supreme artist. So every student has his own style of approaching this question and giving the answer in the most beautiful manner. So you be at your own, never change. You are complete. So just understand this whole working procedure and fasten up. Do it again and again. So AB. AB, what is the potential difference then? 5 ampere into 4 ohm, 20 volt. AB section 20 volt. BC section 10 volt. AD section. AD section is what is AD is the 2 ampere current into 10 ohm. That is 20 volt. BC section again 10 volt. BC section 10 volt. Again, what is that? We have all found out now. Then AB section 20 volt, BC section 10 volt, AD section 20 volt, DC section 5 into 5, 2 into 5, 10 volt, 2 into 5, 10 volt. We have found out all the answers now. So, coming to the, we have completed whole what is to be found out. Coming to the third question. I have don't think I have over explained this question, because there are some people facing difficulties. It is for them. Please support me. The thing is that question 3 is dealing with an ammeter reading or ampere meter. Ammeter is used to measure the ampere. So ammeter, ammeter. That's the language flow. Ampere meter has been changed into ammeter. And voltmeter, no, voltage meter. That is changed to voltmeter. So this ampere measures the ammeter measures the ampere, and the voltmeter measures the voltage. And by now, just a figure is given. Find out the ammeter and voltmeter reading. That's the essence. Readings of ammeter and voltmeter. How do you find out? The voltmeter is connected across this cell now. A cell of 6 volt is given. Internal resistance R is there. Okay, this cell now offers an internal resistance R. And this is connected to the other side. Voltmeter reading you want to find out. And again, this cell now is coming through a 6 ohm resistance and a 4 ohm resistance, and again ammeter is connected over here. Okay, ammeter is connected in series to a cell, and voltmeter is connected in parallel. That is the essence. You study this also. So this diagram is the what is to be understood well. And then what is the ammeter reading? That means I is asked. I is equal to, you just write V is equal IR, no? So when the ammeter reading you want to find out, then this R also, this internal resistance also will come into play. Look at this. What is I have written? V is equal to IR equation. Then I is equal to V by R. Then this R is involved. This internal resistance is also involved, plus the 6 ohm also, plus the 4 ohm also. That is written over here. They involved all thing. So the I current is equal to 6 by 11 ampere. This is the correct answer. Then what is the voltmeter reading? Voltmeter reading says terminal potential difference. What is terminal potential difference? The terminals, no? What all is here, no? That's it. So voltmeter reading is giving the terminal potential difference. We want to find out that voltmeter reading, then just use this. What all current is passing through? Now V is equal to I into the resistance. Just take without this internal resistance, because now this is the terminal potential difference. Do not include the internal resistance. Just this terminals. Now it is encountering what all? Yes, 6 and 4. That's it. That's it. So the terminal potential difference or the voltage reading or the voltmeter reading is equal to 6/11. That is the current flowing through this line. And from positive to negative into 6/11 into the resistance encountered, 6 plus 4. That is 10. That is 6 into 10, 60. 6/11 to 10. 60/11 volt. Okay, guys, please support me, help me. Please like, share, subscribe my channel. I'll be there for you. I will be coming back with a lot of entrance oriented, making it very easy for you. I'll be there for you. If some Kerala Malayali people also are watching, please support me, because this is for the usage of CBSE students in the national level. So I'll be back. Be cool, be happy in this crisis time. Also, try to be cool, guys. The one is with you. Bye.